all right angles are congruent. Makes sense, right? Because congruent means the same shape and size, and every 90-degree angle is a right angle, and every right angle is 90 degrees, and so they'd always have to be congruent because they're all 90 degrees. So don't even know why that one has to be a theorem. To me, that should just be a... Right, if one angle in a linear pair is a right angle, then the other one is also a right angle. Okay, linear pair makes a straight line, which means we add up to 180 degrees. That's the vertical angles. But they do make two sets of linear pair. Yeah. Yeah, so the linear pair is any sets of angles that make a straight line. So 180 degrees, and if one of them is 90, then the other one has to be 90 because 180 minus 90 is 90. So this is another one that should make sense. So if one's a right angle, the other one has to be a right angle. So 12 and 13 are good? Okay, we have theorem 14, which is the angle bisector theorem. Okay. This one says if WY is the bisector of XWZ, so here's WY, this is my bisector, then this angle here is the same as this angle here, which is half of the whole thing. So the measure of angle 1 is equal to measure of angle 2, which is equal to 1/2 of the measure of the whole thing. So, for example, if angle 1 was 32, angle 2 would also be 32, and then XWZ, sorry, I should put the little n's in front, would have to be 64. Not too bad. Okay, congruent complement theorem. If two angles are complementary to a third angle, so if, say, angle 1 and angle 3 equal 90, complementary, and angle 2 and angle 3 equal 90, complementary, then that means angle 1 is the same as angle 2. And if you think about it, that should also make sense, because if 1 plus 3 is 90 and 2 plus 3 is 90, well, the 3's are the same, so 1 and 2 have to be the same. Does that make sense? Okay. And the same thing with congruent supplements. If 1 and 3 is 180 and 2 and 3 is 180, well, that means 1 has to be the same as 2. So same idea, just one's with 90s and one's with 180s. And then this common angle theorem is the same as that common segment theorem. I'm going to go ahead and number these 1 and 2, and I'm going to call this whole thing here 3 and this whole thing here 4. Okay, so this is angle 1 is congruent to angle 2. Then angle 3 is congruent to angle 4. So if these two little pieces are the same and you add this middle piece in, you get a bigger angle that's the same. And the same over here, if you have the bigger angles and then you take out the middle section that's the same, then the little angles will be the same. So it's the same thing as that common piece of segment that you were adding and subtracting, except this time you're adding and subtracting a common piece of an angle. So they're sharing the same size piece. So if they were already the same size and they have the same size piece added or subtracted, then they stay the same size. Does that make sense? So here we have the common angle. Okay, so I have BOD is 50. So BOD is from here to here. That's 50. BOC, that's this little piece in here, is 8. I have that AOB and COD, let me do this, are the same size. So that means that these two will be the same size. Okay, and I want to find this one. Exactly. Since the whole thing is 50, this piece is 8, I take 50 minus 8 and I get 42. And since this is 42, that would also be 42. Not too bad? Yeah. Okay, now we have MLP. This is sort of the same thing as the multiple segments that we were adding together, except now we're going to add multiple angles. So MLP goes from M all the way to P. So we're going to add 24, 43, and 24. So that's 67, and 24 is going to be 7 and 4 is 91. Okay, and then QLN, change color. QLN goes from Q to N. So we're going to add 43, 24, and 43. So 86 and 20 is 106, and 4 is 110. Not too bad? Okay. This is just like that last example. So EOG and FOH are the same. So EOG, that's this one. And FOH is this one. So these two are the same size. GOH, this little piece right here, is 14. And FOG, this part in the middle, is 37. And we want to find EOG. Well, if I add these two pieces together, I'll get this length, or degrees, not length. So this is 51 degrees, which means this one will also be 51 degrees.
So it's on this side.
Yeah. And then IOK, that's all the way from here to here, is the same as JOL. KOL, this little bit right here, is 19. And then between J and K is 93. And we want to find IOK. So we want to find this whole length. Well, this whole length is the same as this whole length, so I'm going to add again. And so it's 112.